So for question, it says so, this is the input impedance, which is basically the impedance between the positive terminal of the amplifier. This is the symbol of the amplifier. This is the input impedance, and this is the output impedance, which is the impedance right before the output of the amplifier. So that's formally. So input impedance, Zn, is the impedance presented at the input between the inverting, this is the inverting, and non-inverting, which is positive terminals. The output impedance, which is Zout, is basically the impedance in series with the output, which is this one. Now, the values that the impedance can take. Ideally, we want the input to be infinite, so infinity. We want the output to be 0. But in reality, it's as high as mega ohms, in the range of mega ohms and 10 to the power 12. So 10 to the power 6, 10 to the power 12 volts. For the real output, it can go from few ohms, meaning from like 0 to say 5 ohms. That's it. Okay, now so uh, what? Let's say I. Basically, what do we notice here? The sign are not inverting, not inverting amplifier. Okay. Number 2, it's V out equal to quarter Vn, meaning that V out over Vn, which is in that case is equal to the gain or A, how much it's amplified, is equal to 1/4. So therefore A is equal to 1/4. So how do we draw this? This is the symbol of the amplifier. Since it's non-inverting, this is the feedback. And what else? So we have two resistors, R1, R2. We choose R1 and R2 because it's the simplest configuration, since it's not inverting. It's a non-inverting amplifier. So for that amplifier, this is V out. Okay. So V out is equal to R2 over R1 plus R2 multiplied by Vn. Okay, so R2 over R1 plus R2 or Vn. So V out over Vn, which is equal to A, is equal to R2 over R1 plus R2. Therefore, just put this on the other side. It's gonna be AR1 plus AR2 so AR is equal to R2 minus AR2. Therefore, when you divide by A in both sides, you get R2 over A minus R2. and then take R2 as a common factor, you get R1 is equal to R2 multiplied by 1 over A minus 1. And then substitute A by quarter, so what you get is R1 is equal to R2 multiplied by 4 minus 1, and then R1 is equal to 3R. So you can select any value of R1 and R2, so let R2 is equal to 1 kilo ohm, therefore R1 equal to 3 times 1, which is 3 kilo. So going back up, you can just say that this is 1 kilo ohm, 3 kilo ohm, and this is 1 kilo ohm. So that's how you design the output, the amplifier. For part 2, we need to design an amplifier where Vout is equal to minus third Vn. So as you can notice here, it's a negative. So the output is negative negative of the input voltage. Therefore, it's an inverting amplifier. Therefore, this is the configuration of the inverting amplifier. You need feedback at the positive terminal with a distance from R2, and then here, then other R2. This is Vn, this is R1, and this is grounded. This is Vn. Okay, so the law is simple. It's basically Vn over R1 is equal to Vout over R2. Therefore, what's A in that case? A is Vout over Vn, which is minus third. Yeah. Therefore, A is equal to Vout over Vn equal to R2 R1 is equal to minus 1/3. Therefore, multiplying both cross multiplication, so what you get is 3R2 R1 is equal to minus 3R2. So let R2 equal to 1 kilo ohm, R1 is equal to minus 3 kilo ohm. 3 kilo ohm. There is a minus sign, so it's minus. So therefore it is, yeah. So 3 kilo ohms exactly. That's it. So for this question, Vout is equal to 12 Vn. It's non-inverting. The amplitude is Vout over Vn, which is 12, which is greater than 0, which is different from the first one. The first one here was also non-inverting, and 0. That's why the configuration is different here. It's easier when you manipulate the variables. We'll see now. So if this is R2 and this is R1, Vn is equal to R2 over R1 over R1 plus R2 multiplied by Vout. So that's the law for this configuration, and therefore Vout over Vn is equal to the amplitude or the gain. So R1 plus R2 over R1 is equal to A. So if you divide Vout over Vn, you flip this That'll be R1 plus R2. Then you multiply both sides by R1, you'll get AR1 is equal to R1 plus R2. Then you switch terms and then you'll have R2 is equal to R1 A minus R1. Let R1 common factor. Then substitute A as 12, so you'll get R2 is equal to 11 R1. Let R1 is equal to 1 kilo ohms, therefore R2 will equal 1 kilo ohms, the R2 will equal 11 kilo ohms. Question 4. So in that case, it's a difference amplifier where you have two inputs, V1 and V2, and you amplify each one of them, and then you get the difference between them. So the schematic of this is the following. As you can see here, V1, the first source is at this part, the signal, and the second source is at this terminal. This is V out. So we know that since this is V1, this is always equal to this. Look at this node. So it's gonna be V1. And at this node. Okay. So given this, we're gonna do the nodal analysis, meaning that we're looking at the currents going here. And the currents going here. So the node analysis is as follows. This is a current, right? And this is a current. So these two currents sum up to this one. So this current plus this current is equal to this current. So I1 plus I is equal to I2. How do we find I1? I1 is basically V1 minus V2 over R2. So V1, so this is I1 minus V2 over R1. I2 is what? I2 is the current here. So it's V1. This is V1 as well, because it's from here until the ground. So V1 minus V out. V1 minus V out over R, which is the resistance here. What's I2? Basically, it's just V1 over R, because there's no other resistance. So V1 over R2. Sorry, the V1, the current is going the other way around, going outward, and it's coming from here. So here, and it goes both ways. So what just happens is V2 minus V1, V2 minus V1, because this is the larger one, minus the smaller one. So this is the direction of the current. And then the same goes for this. I2 is V out minus V1. So the current goes that way. And then V1 minus ground, which is minus 0 over R2. So the current goes that way. Now, we substitute, so it's V2 minus V1 over R1 plus V out minus V1 over R is equal to V1 over R2. So we're just substituting the current values. And then we manipulate, so we do the following steps. Here we just separate them. And then here we put V1 over V1 on one side, so we just shift it on the other side. So V1 over R, V1 over R1, V1 over R2. Then we take V1 as a common factor, so what's left is 1 over R plus 1 over R1 plus 1 over R2. And then we put this on the other side, just like that. And then we multiply by R both sides. So we left R over R1 is equal to 1, and then R over R1 plus R over R2 minus R over R2, V2. Therefore, this is A and this is B. From this, A V1 minus B V2. Okay, so A is equal to 1 plus R over R1 plus R over R2, and B is equal to R over R1. So we'll continue in the next video.